Hey, today I want you to know if you look at tables of values, I want you to be able to figure out do those tables of values represent linear functions? And so that's what I'm going to show you how to do today. So, a couple things I want you to remember linear functions have a constant rate of change, and if you were to graph them, they would form a straight line. Okay. So we don't actually have to graph these tables of values though to know if they are linear or not. We actually can just look to see if there's a constant rate of change. So just as another reminder, this isn't new information, but just as a reminder, to find the rate of change between 2 points, you divide the change in y, the vertical change, by the change in x, the horizontal change. So the rate of change is change in y divided by change in x. And that should look familiar because that is how we find the slope of a line. We divide the vertical change or the change in y by the horizontal change, the change in x. So what we're doing really is we're looking for the rate of change. We want to know if it's constant. So I'm going to show you how to do that on each of these. So the first thing I'm going to do is I'm going to look for my change here from 0 to 5. So from 0 to 5, that is an increase of 5. And my change from 10 to 20 is an increase of 10. And if you can't just see that, know that I could figure that out by doing 5 minus 0 is 5, and 20 minus 10 is 10. And so then I'm going to ask myself, okay, well, what is the rate of change of from this first point, the 0, comma 10, to this point, 5, comma 20? Well, I want to take my change in y and divide by my change in x. So I'm going to do that down here. So change in y divided by change in x is equal to 10 divided by 5, and 10 divided by 5 is equal to 2. So far my rate of change is 2. Let's see if it stays constant. So now I'm going to jump from 5 to 7 here on my x side, and that is an increase of 2. Again, I do that by 7 minus 5. And then 24 minus 20 gives me an increase of 4. So that's plus 4. Okay. And so if I divide that, 4 divided by 2, right here, 4 divided by 2 gives me 2 again. So I still have a rate of change of 2. One more try. So from 7 to 10, that's an increase of 3. Again, I did 10 minus 7 to get that. And then from 24 to 30, that is 30 minus 24 is 6. So my vertical change, my change in y divided by my change in x, would give me 6 divided by 3, which gives me 2 again. So this is a linear function because it has a constant rate of change. When I divided my change in y by my change in x, I always got 2. So yes, this is linear. Okay, let's go to this next one, and let's do the same thing. So I'm going to find my change in y. So from 0 to 2, that's an increase of 2. And from 1 to 5, that's an increase of 4. Okay, so my change in y divided by my change in x is going to be 4 divided by 2, which gives me 2. And so I'm going to do that again. I'm going to go from the 2 to the 10, and 10 minus 2 is 8, so that's an increase of 8. And 5 to 13, that is also an increase of 8. So, because 13 minus 5 is 8. And so my change in y is 8 divided by 8. So 8 divided by 8, that's actually equal to 1. So I actually can stop right now because those are not constant. There's a rate of change of 2 from this point to this point, but a rate of change of 1 from this point to this point. That is not a linear function. So I'll say no, this is not linear. And that is how you can determine whether a table of values represents a linear function.